I talked about column, square or rectangle or circular, side or spiral, but I'm talking about a short column. We have axial force. This axial force called concentric axial force. This expression is very important. Concentric means at the centroid of this column, the P ultimate is applied. At the centroid of this column, we have P ultimate. We have another expression will be covered today. Eccentric. Axial force with distance E. Probably sometimes, actually most of the time, you have a column, looks like this. Here is the centroid of this column, and your beam rested on this column like this, at this location, for any reason. So this beam will apply a reaction at this location, P ultimate. And the centroid of the column is here. So we have a distance in between called eccentricity. If you multiply P ultimate time this value of eccentricity, force time distance, you can get a moment which called M ultimate. So our topic today, I'm gonna talk about column, short column. We didn't talk about long column. We didn't consider buckling. I'm talking about short column. Buckling is not considered. It's not an issue. Next week, I will talk about buckling. But right now, column under the effect of P ultimate and M ultimate, or under the effect of P ultimate and E. Same meaning. Same meaning. If I'm talking about P ultimate and eccentricity, the final conclusion, we have axial force and moment, because P ultimate time E equal M ultimate. Any question? Looks good. Looks good. So today I'm gonna talk about short column under the effect of axial load and bending moment. I can tell you in a different expressions. Eccentric load, same meaning, because eccentric load means P ultimate and E. So probably the problem will give you P ultimate and M ultimate directly, or I will give you P ultimate and eccentricity. If the second case is exist, so I can say M ultimate equal P ultimate time E. So guys, during the homework, be careful about this point. Which homework? Homework number 7, I think. The first one is side column. The second one is a spiral column. You can do it right now. 1 and 2. But for number 3, Be careful. We have normal P and E, eccentricity. We have P and eccentricity. So this column is eccentric column. Any question so far? This point is very important. If you have eccentricity, that means we have a moment. So if you have eccentric load or moment, we need to use something called interaction diagram. Why? This interaction diagram is a relationship between the applied moment and the applied normal force. What you mean? I mean this concept. If you have a column and you have another column and you have another column, the first column under the effect of concentric load. I believe if you calculate your calculations, the design, the capacity of this column of A Pn probably will be 600 kip, because the load is applied at the center of the column. It's concentric. But if this column under the effect of moment and load, I believe this moment, which is 30, for example, will make the capacity of this column, it's not 600, it will be 500. Why? Because some of the column capacity is exhausted due to the effect of the moment. So the remaining capacity for axial force for P will be smaller. And that makes sense. If this moment increased instead of 30, 50, I believe the axial capacity will be reduced more and more. That makes sense? If you draw a relationship between the applied moment, which is 0 here, and the axial capacity, you will find this relationship. This relationship called interaction diagram. The meaning of interaction is due to the two effects, P and M. So we need to understand the interaction between the two effects. So can you watch? If the moment is 0, I believe you will get the maximum or the greater or the greatest value of P. Once the applied moment increase, the capacity decreased. The axial capacity, I'm sorry. And that makes sense. So we have something called interaction diagram, which is a relationship between the the applied moment and the applied axial force. Interaction effect between M and N. Okay, this part is very simple, very easy, just steps we need to follow. But the first important part, I need each one of you to understand what is the meaning of interaction diagram. It's just a relationship between moment and P or N, represent a combination between the two effects. As I told you for this little example, if you don't have moment, we have big axial capacity. If you apply a little bit of the moment, the load will be decreased. Why? Some or a little bit of the capacity of this column is exhausted due to the effect of moment. So the remaining capacity will not be the same like this one. And if this moment increase, the capacity, the axial capacity will decrease. So if you draw a relationship between moment and the axial capacity, you can find this curve, which you call interaction diagram. It's very important to understand this concept. Sometimes, if you have a moment on the column for any reason, sometimes we put reinforcement uniform distributed. Sometimes we put this reinforcement on this side and this side because the moment is applied like this. Or in this side and this side if the moment is applied like this. Or if your column is a circular column. Or sometimes your column is a square, but your steel reinforcement looks like polar distributed. I will ask you a question and I need a good answer. Are you ready? I will ask a question and I will need answer. Do you remember where steel reinforcement is located? At tension or compression? So if you have a moment like this, do you know where is the tension side and the compression side? Yeah, thank you, Oliver. Yeah. I think the tension side will be at the tail of this arrow and the compression at the head of this arrow. And that makes sense. So you should put steel reinforcement on this side. But where is the question? The question is why we are using this distribution, why we put reinforcement here. The tension side is here. Guys, I'm talking about column, not beam, but the same concept. So the tension is on this side. So why I'm putting reinforcement on the other side, which is under compression? Any answer? Any answer? Minimum. This area steel is equal to this one. Wow. The same area steel? Yes. If you put here 5 bars, 5 bars. If you put here number 10 bars, the same number. So everything's the same in both sides. How can I increase the resisting moment? The reinforcement are in compression and the concrete is good. Concrete is good in compression. Your column is short column. Buckling is not considered. We don't have issue with buckling. No, no. Okay, guys. I will explain it. Right now, I'm talking about column. The main source of moment on column is lateral load. And the lateral load probably from wind or earthquake. So if you have a column like this, and your lateral load, and this column is fixed here. Your load or lateral load coming from this direction due to wind, earthquake, or whatever. I believe this side will be under tension and the other side will be under compression. So we need steel reinforcement here. Do you agree? Probably in the next time of the wind, probably in the next time of the wind or earthquake, they are coming from this direction. So tension will be here and the compression will be here. So steel reinforcement here will be required. Probably in a third case, your wind load coming from this direction. So probably tension in this side, compression on the other side. So I think the perfect distribution for reinforcement in a column under the effect of moment, probably this one or this one. If you cannot figure out which direction of the moment, sometimes like this, sometime like this, sometime like this, sometime like this, due to the effect of lateral load, I believe uniform distribution will be the best solution. But if your moment, due to the effect of anything else, which is constant all the life, I believe nothing will change. So I'm going to use this distribution in one side and the other side. But wind and earthquake everywhere. Also snow, load, rainfall, all of this stuff make this distribution is the best distribution. So because I cannot figure out the actual direction of the moment, we need to make this uniform distribution. Anyway, it's not a big deal for our course. How can I use interaction diagram? Very simple. Very simple. I will give you the ultimate load, P ultimate, and I will give you the M ultimate, and I will give you the column, concrete dimension of the cross section. Just a hint. If the cross section of the column is not given, I can get the area gross of the concrete from this expression. Just to divide P ultimate, divide 0.6 F prime C. If the concrete cross section is not given. And once you get area gross, I can assume this length and I can figure out the other length from area gross. If concrete cross section is not given. Also, Probably sometimes I will not give you M ultimate. I will give you P ultimate and E eccentricity. So you can figure out the value of M ultimate. How? P ultimate time E equal M ultimate. Any questions so far? Looks good. Looks good. So we are looking for rho and then area steel. How much steel reinforcement in this column? If the cross section is not given, I can figure it out from this equation. If it's a given, that's fine. First step, we need to figure out the value of Pn, which equal P ultimate divide phi. P ultimate divide phi. Phi equal 0.65. Calculate the nominal bending moment, Mn equal M ultimate divide phi. One more time. Mn equal Pn time E also. So P time eccentricity equal Mn. So if E is given, I can figure out the value of Pn, then I can figure out the value of Mn. It's very easy. So from step number 1 and step number 2, I need Pn and Mn. If Pn and Mn is given or are given, so forget this one and this one. I believe in the homework for this one, Pn is given. Okay, 500 kip, that's fine. So I don't need the first step. Eccentricity is given 6 inch. So Mn equal 500 times 6 divide 12. Please make sure your dimension in feet. So your moment will be 250 kib foot. Here is Mn and Bn without these steps. But if the given is P ultimate and M ultimate, I need to do the first step and second step, like this problem. The given is P ultimate. How much? 300 kib. So please go ahead and find out the Pn equal 300 kib divide phi 0.65. And the eccentricity is given. So I can figure out the value of Mn equal Pn, which is this value, time 10 inch 10 divide 12 to be in feet. Your value will be kept feet. So please be careful which values are given. After these two steps, I need you to put your hand on two values, Pn and Mn. Any question? Looks good. If P and M are given, so you can figure out the eccentricity. If eccentricity is given, I don't need this step. So after the first three steps, I need to figure out the value of Pn, the value of Mn, the value of eccentricity. If one of them is given, that's fine. Figure out the rest. We have a value here called gamma. How can I figure out this value? It's very simple. This length of the beam equal h. The length between this layer of the reinforcement and this layer, gamma h. These two dimensions will be given. So I can figure out the value of gamma, and we will see an example. Fifth step, we need to get this expression, these expressions, value of Kn and the value of Rn. Kn equal Pn divide F prime C area gross. Area gross, the total cross section of the column, B time H. Rn equal Pn time E divide F prime C area gross time H. H, the larger dimension of the column, H. Once you find Kn and Rn, go ahead and use this interaction diagram. But make sure you are choosing the correct one with F prime C and F yield and the value of gamma that you calculated here. We have different interaction diagrams with different values for F prime C, different values for F yield, and different values for gamma. Okay, I selected the correct one. What should I do? Nothing. You are almost done. What is the value of Rn here? This one, please figure it out. For example, this value. Then what is the value of Kn? This value, put it here. Go up, go horizontal. At this intersection, this curve for rho equal 0.08. This curve for rho equal 0.07. So your point in between, so your rho probably equal 0.075. Rho equal area steel divide BH, so I can figure out the value of area steel. Let's do example. Let's do an example. But if you have any question, let me know. These interaction diagrams, you can get them from tables. Go down. Starting from page 657. We have many interaction diagrams. For circular column, for rectangular column, uniform distribution, uniform, 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 non-uniform. One on this side and one on this side. So we need to figure out this value. Here, F prime C equal 4, KSI, F yield equal 60, gamma equal 9.9. We have a different, gamma equal 0.8. We have a different value, gamma equal 0.7. So we need to figure which interaction diagram I'm gonna use. Let's do this example. Very simple calculations. Very simple. Let's start. For this column, we have a column, short column, 14 times 20. Perfect. So the cross section of the column is given. B is 14, H is 20. From the given dimensions, do you remember what is the value here? This value equal gamma H, which is the distance between this layer of steel reinforcement and this layer. So gamma H is 50 inch. What is the value of H? The total height of the column is given 20. So gamma times 20 equal 50. So what is the value of gamma? 15 divide 20 equal 0.75. I'm gonna assume 8.8. We need it to be 0.6, 0.7, 0.8, 0.9. Okay, let's read the problem carefully. We have a column is used to support the following load. BD equal 125. BL 140. MD 75. ML 90. All of us know the meaning of D, dead, load. The meaning of L, life, load. Brock, did the problem said these loads are factored load? No, the problem didn't say factored load. The problem said we have dead, we have life. So if you are looking for P ultimate, it will be 1.2 P dead plus 1.6 P life. 1.2 times 125 plus 1.6 times 140. If you are looking for M ultimate, it will be 1.2 M dead plus 1.6 M life. 1.2 times 75 plus 1.6 times 90. And that makes sense. 1.2 times 125 plus 1.6 times 140. 374 kip. 1.2 times 75, 1.6 equal 234 kip foot. Any questions so far? Looks good. So P ultimate and M ultimate are given. First step, Pn equal P ultimate divide phi. P ultimate 374 divide 0.65. What is the value? Second step, Mn equal M ultimate divide phi. 234 divide 0.65. What is the value? Third step, eccentricity equal, you have two options, M ultimate divide B ultimate or Mn divide Pn will give you the same answer, believe me. So 374 divide 0.65, it will be 575.4. 234 divided 0.65, it will be 360. This one is skip, this one is skip foot. If you divide this one by 575.4, the eccentricity will be 0.625 feet, which equal 7.5 inch. The first three steps, we need to figure out the value of Pn, the value of Mn, the value of eccentricity, and we are done with the value of gamma. Any questions so far? Looks good. Next step, we need to figure out the value of what? Pn equal Pn divide F prime C area gross. Rn, which is Pn time E divide F prime C area gross time H. Go ahead and put your numbers. PN 575.4. F prime C for this column 4,000. Area gross for this column, how much? 20 times 14. We have issue here. Do you know what is the issue? Do you know what is the issue? Units. Thank you, Cody. Units. BN in KIP 4,000 PSI. This one in inch square. So inch, I don't have issue with inch, but I have issue this one in pound, this one in KIP. So I have to multiply it by 1,000. Your units must be consistent. So 575.4 times 1,000 divide 4,000 times 20 times 14. This value equal 0.51. One more time. PN 575.4 times eccentricity. What is the value of the eccentricity? I will use the feet or inch, 7.5. Because if you use the feet, you will convert it, don't worry. 4,000 area gross 20 times 14, H 20. Make sure this value will be multiplied by 1,000 to be in pound. This one in inch, that's fine. This one is inch pound per inch, that's fine. This one in inch square, that's fine. This one in inch. So everything in pound, everything in inch, you are good. You are good. This value will be 0.2. 0.2. So just to make sure, F prime C equal 4,000 PSI or sometimes 4 KSI. F yield 60,000 PSI, sometimes 60 KSI. Gamma equal 0.8. So I'm looking for one more thing. The steel reinforcement on two sides, this side and this side only. So let's try to figure out which interaction diagram. FC is 460, but gamma equal 0.6. No, not this one. What about this one? Gamma equal 0.7. No, not this one. We can use this one. We can use this one. If concrete 4,000, yield 60,000, gamma equal 0.8, steel reinforcement in two sides. The value of R n 0.2. Where is 0.2? This value. The value of R of Kn 0.51. 0.5. This one is 0.4. This one is 0.6. So 0.5 will be in between. Something here. So can you go horizontally? Can you go vertically? This intersection at curve with rho equal how much? 0.02. That's it. Rho equal 0.02. This rho equal area steel divide B times H. So 0.02 equal area steel divide 14 times 20. So area steel equal 5.6 inch square. How many bars and what is the size of this bars? Make sure this number must be even number. Why? Because your steel reinforcement in this side will be the same like this side. So if you put 5 here, you have to put 5. If you put 4 here, you have to put 4. So the total number must be even number. So go back also to the table, which size you are going to use. So I'm gonna use probably how much the area steel? 5.6. 5.6. Okay, let's try number 6. The area is 0.44. So I'm gonna use number 6, and I will divide this one by 4. The number is 12.7, so I'm gonna use 14. 14 means I'm gonna put here 7 and here 7. If you are feeling 7 is too much, okay, go ahead and use number 7. Probably 7 will be good. 0.6, so 5.6 divide point how much? 0.6. This number will be 10. Probably 10 will be better. It's up to you. It's up to you. So the final answer for this reinforcement, I'm gonna use 10 number 6, or I'm sorry, 10 number 7, or 14 number 6. I think 10 number 7 will be better. 5 and 5 will be good. Any question? Is that in squared? What you mean by in squared? This column is not squared. It's 14 times 20. Yeah. The area still here, inch square, because it's area. It's area. Okay. Okay, let's do one more example. If your column under the effect of M ultimate and P ultimate, I don't care. It's a tied or a spiral column, because we are in a different category right now. We are talking about a column under the effect of P and M. So we are using interaction diagram. I don't care if your column is a spiral or tied. It's not a big deal for me. Previously, no, we need to figure out what type of column. Is it spiral column or tied column? Because you are talking about only P ultimate. We don't have moment. So make sure which category you are designing a column. Okay, we are designing a column under the effect of P ultimate and M ultimate. This column, it's not given. We have a short square column for the following condition. P ultimate 600, M ultimate is 80 kip foot, F prime C if yield is given, and bars uniformly around all 4 faces of the column. Where is the column? I cannot watch, I cannot see the column. What are the dimensions of the column? Please go back to my notes. If the concrete cross section is not given, I can figure out the area gross equal P ultimate divide 0.6 F prime C. So first step, I need to figure out the column dimension. Area gross equal P ultimate divide 0.6 F prime C. P ultimate is given 600. I will multiply it by 1000. Why? Because F prime C inbound PSI 4000. So your area gross will be 250 inch square. The problem said this column is a square. So how can I convert this area gross to square column? This area gross equal something times the same something, because it's a square. So I'm gonna use square root of this value. It will be 15.8 times 15.8. We don't like decimal numbers, so I'm gonna use 16 inch times 16 inch. So the column dimension will be 16 times 16 square. And the problem said the steel reinforcement will be uniformly distributed. So your steel reinforcement looks like this. Guys, the distance between this reinforcement to this edge, I'm gonna assume it 2.5. The distance between this reinforcement and this edge, I'm gonna assume it 2.5. Anybody can tell me what is the remaining distance here between this reinforcement and this reinforcement? Looks like how much? 11. This 11 inch alpha h equal 11. I'm sorry, not alpha, it's gamma. Guys, put in your mind that the distance between this reinforcement and this reinforcement equal gamma h. So gamma h in this case equal 11 and h equal 16. So I can figure out the value of gamma 0.68 something. So probably it will be 0.7. Because from F prime C, F yield, and the gamma, I can figure out which interaction diagram I'm gonna use. Okay, looks good. P ultimate is given 600. So I can figure out the value of Pn. M ultimate is given how much? 80 kib foot. So I can figure out the value of Mn equal M ultimate divide phi. Eccentricity is not given, so I can figure out eccentricity equal M ultimate divide P ultimate or Mn divide Pn. Gamma 0.7. I can figure out the value of Rn and the Kn. You remember? Kn and Rn. Pn divide F prime C time area gross. And this value Pn time E divide F prime C area gross time H. Based on this one and this one, I can figure out the value of rho and I can figure out the value of area steel. Do you know which interaction diagram I'm gonna use? No, not this one. Or not this one. Not this one. Not this one. Probably this one. But this one is alpha gamma equal 0.6. Why this one? Because uniform distribution of steel reinforcement. So I'm gonna use this one. Gamma equal 0.7. F prime C equal 4,000, 60,000, and uniform distribution. So please put your value of Rn, put your value of Kn, so I can figure out the value of rho. Then I can figure out the value of area steel. Very simple. Very simple calculations. Okay, if you have a circular column, the only difference you have special interaction diagram. You need to figure out where is the interaction diagram for circular column. Okay, any question?